so start with announcements. So due today, Wednesday, September 9th, is the questions for 1C. So this is what we talked about, mainly on the PowerPoint, so it's a lot of definitions. So it might even help if you go through your FChem Exam 1 review. It's the packet, it's like the 5-pager posted on Blackboard, and the title says FChem Exam 1 Review, Chapter 1. And it's just, the first section is define the following. So I want you to go in the PowerPoints, and most of them are the 1C PowerPoints. That's where most of these definitions are. And write them down, or the book. The book has all these definitions as well, so you can go through and write them down. I didn't put them here for you because it actually helps you to remember when you write things down. So a lot of the questions will be on definition type things. There's also density questions on the 1C. So since the questions are due, the discussion's also going to be due. And I've seen a lot of people already did the discussions, so you just need to post a reply twice. So everyone's been keeping up with that pretty decent. So our exam is coming up, it's due Sunday, okay? It's going to open up on Friday morning, like 5 in the morning, I think is when I have it set for it. And not that I expect anyone to take it at that time, but you can take it anytime from Friday through Sunday. Okay, so find a quiet space, 2 hours, good internet connection, start the exam at that time, okay? You do have 2 hours, it's 36 questions. Usually our exams are about this long when we have them in person, and we usually have an hour and 15 minutes. So I'm giving extra just so that you have time to look through things. I recommend you have your calculator ready. I recommend that you have probably your exam review filled out and ready. Any equation sheets that you need, have those out. Okay? It'll just save you some time in the long run. I did post practice exam questions for each of the 3 sections, 1A, 1B, 1C. And the reason I posted those is so you can see the setup is very similar to what you're going to see on the exam. So it shows you 1 question at a time, you can't backtrack, and they're mainly multiple choice questions. I think there's 1 fill in the blank, but other than that, it's multiple choice. So, questions on the exam. Deadline midnight on Sunday, and I'll be putting out reminders. I'm trying to be better about that, reminding people when things are due with announcements and stuff via Blackboard and email. All right. So, let's get started. So we're starting with the 1-pager, the Exam 1 review problems. And I'm just going to work through these. Hopefully work through them together, I should say. And we'll see how far we get. If we don't finish all of the review, I will, of course, continue on Friday. So, all right. I'm just going to start with number 1, where it's asking you to classify the following as a physical change or a chemical change. So these are some of the definitions you'll need to know from the PowerPoints for this week. You need to know more than just the definitions, though. You need to be able to apply them. Okay, so that's what this example is having us do. So the first example is gold melting. Okay, what I'm going to write over here is the definition of physical and chemical change so that we can try to apply and figure out what this is. So for physical change, your book's going to give you a more elaborate definition. It's usually a change that can be reversed. Is one way to recognize it. It's also a change in, what's the word I'm looking for? Solid, liquid, gas state. Here we go. Change in the state, not the chemical composition. So for a chemical change, atoms have been rearranged, bonds have been broken. So we're going to take what we know about physical change and chemical change and apply it to the three examples here. So gold melting is the first, we have cheese molding, and I'll just put moldy cheese to make that more specific, and then photosynthesis. All right, so gold melting. So if gold is melting, is it changing the chemical composition of gold? Once it melts, is it still gold? It's still gold. Okay, so it's not going to be a chemical change. Atoms weren't rearranged, we don't have a new compound, no bonds were broken, no new bonds were formed. It's the same compound, it's still gold. What did happen was the state change. So when I say state, I'm talking about solid, liquid, gas. What happened is solid gold was melted and turned into a liquid. So that's a clear indication of physical change, change in the state. Another way to recognize it is it's a change that can be reversed. Why do they usually melt gold? So they can put it in a mold and make jewelry or something else, right? So that it's going to eventually harden again. It's a reversible process. So for both of those reasons, it's going to be physical. So for moldy cheese, so this one I'm talking about, you go in your refrigerator and you're at green stuff all over your cheese. Okay, not actually a cheese mold, but moldy cheese. What do you think that would be, physical or chemical?
Chemical.
Chemical, why?
Because it's had something new on their mold.
It's something new, it's something new growing. It's not cheese, you don't want to eat that, right? Because its bonds have been broken. It is breaking down the cheese and forming something new compound. Atoms are rearranging. Okay, so yes, chemical. Photosynthesis, I might have used this in the PowerPoints, but for photosynthesis, I'm talking about the process where plants take in sunlight and carbon dioxide and they spit out oxygen and grow. So do you think that would be physical or chemical? Chemical? It actually is chemical, because I just said they're taking CO2 from the air. I mean, they're taking sunlight and other stuff, but then they're giving out oxygen for us to breathe. Now, it's obviously way more complicated than this process, but their atoms have been rearranged, new compounds have been formed. Okay? They actually spit out oxygen and sugar, which has carbon and hydrogen and stuff in it, but so since there's actual chemical reaction going on, so anytime there's a chemical reaction, that means it's going to be a chemical change. Oops. Ready for the soccer today. So if you haven't watched the PowerPoints at all yet, I do several other different types of examples. There's actually a slide where we just go through examples like this and classify them so you can get more practice with that. Just pause it and try to solve them yourself before I give you the answer. All right, so next we'll look at intensive and extensive properties. So intensive property is independent on the amount. So what this means is the amount does not matter. Does not matter, it does not affect. The other property we're going to compare that to is extensive. And this does depend on the amount. The example I use in the PowerPoint is for an extensive property, you need an extra amount to kind of help you remember that one. So we have number 2 now. Mass of a pencil, mass of anything, density. And I'm just going to add another one that's not on there. let's do boiling point. So BPT means boiling point. We're going to take these three properties and identify them as being either an intensive property or an extensive. Okay, so intensive property, independent of the amount. What does that mean? It means it doesn't matter how much you have, that property is going to remain the same. Okay. For extensive property, does depend upon the amount. That means that whatever property you're talking about, depending how much you have, that could change the value. So an example would be like volume. That would be an extensive property. Because if I am measuring with a graduated cylinder in lab, a liquid, right? It depends how much liquid I have for what the volume is going to be. That property is going to change depending upon the amount of liquid I have. If I have a little bit of liquid, the volume is going to be low. If I have a lot of liquid, the volume is going to go higher. Okay, so the volume will change depending upon how much I have. So since that property is changing with the amount, it's extensive because it depends upon that amount. All right, so with those definitions, let's apply them to mass. So with mass, and I'm talking about a scale, you bring something to a scale, you're going to weigh it. Do you think that would be intensive or extensive? Does the amount of material you're bringing matter?
Yes.
Yes, it does. If you are bringing just a little handful of sugar, okay, to the scale, that's going to weigh less. Your mass is going to be low. But if you have 2 handfuls of sugar, your mass is going to increase. It's going to change depending how much you're bringing. So since it does change depending on the amount, it's going to be extensive, yes. Right. Now let's look at density. So density is what we've talked about in 1C as well with some example problems. So for density, what do we think that's going to be? We'll give you an example. I don't know the density of gold off the top of my head, so I'm changing the example from gold to water. So let's say the density of water is 1 gram per mil. Okay, so if I have, if I'm talking about a bucket of water, or if I'm talking about an entire pool of water. So let's look at the bucket first. What is the density of water in that bucket? 1 gram per mil. Okay, what if I'm talking about a whole pool full of water? What's its density?
1 gram per mil.
So does it matter how much I have? No, the density is going to remain the same. So the density of water is going to be 1 gram per mil no matter how much water I have. I could be talking about a whole lake of water. This is a consistent property that does not change no matter the amount. So if it doesn't change no matter the amount, intensive property. It is independent on the amount. The amount does not matter, that will stay the same. The property will stay the same. So this is intensive. Okay, so let's do boiling point. So does anyone know what the boiling point of water is? Let's use water again. I think in Fahrenheit it's 212. Depends what degree you're talking about, right? And we could actually take this with our temperature conversions and figure out Celsius and Kelvin too if we wanted. But for Celsius it's 100 degrees Celsius. And you can do your calculations to prove that. Okay, so do you think boiling point is intensive or extensive? Intensive, why?
Because it's going to stay at the same temperature, it's going to boil it no matter what.
Right. If you have a cup of water, or if you have a whole, you're making spaghetti and you have a big pot of water, it still has to get up to 212 degrees before it's going to boil. It doesn't matter how much of it you have, it's going to need to be that temperature before you're going to start seeing a rolling boil. Okay? So, intensive. Good. So you will see the definitions themselves, where I might give the definition and then give you choices. Is this describing an intensive, an extensive, a physical, or a chemical? And there's other examples where I might give you a property itself, and you need to tell me what type of property it is. Is it an intensive property? Is it extensive? And on the review packet, the big one, the thick one, you can see, so I'm looking way down at like the definitions, so like 6, 7, 8, 9. I do give some examples in parentheses after those. So for instance, intensive, we just talked about density and temperature, right? Density and boiling point, they're both intensive. So while you're giving your definitions there, you could write some extra examples too to help you once the exam comes. All right, so. Another one. Did I post a practice exam? Has anyone seen? Okay. I'm not sure if I posted it or not.
Talking about in folder 3?
It would be in week 3 folder.
Yeah, like 7 questions for each one.
Okay, so I did the quizzes. All right. I just can't. I've been posting too many things in different classes and I'm forgetting what I put in what class. Sorry about that. Random aside. Okay, let's move on to scientific notation. So we're looking at number 3 on the exam 1 review problems. We're going to express the following in scientific and then write the number of sig figs after it. So the reason we're doing this is just to make sure we're taking into account sig figs. Because when you're going from scientific to normal or normal to scientific, you need to keep an account the sig figs. That's where most people get it wrong, is they don't remember, oh wait, I need to count my sig figs and report my answer correctly. So I'll write these three, couple down. 0. So just a review on going from normal notation to scientific notation. And the nice thing about that big packet is I think I even have instructions on how to do that if you forget. So it would be on the 3rd page. So I should have numbered them. But there's a whole scientific notation / normal notation section which reminds you how to go between the two if you forget. So before I start my scientific notation, I like to do my significant figure counting just because once I start moving decimal points around, I kind of get lost as to where the decimal originally was, and then I could miscount my significant figures. So looking at this very first one, how many significant figures do we have in that number? 1, it's just the 3. Okay, because there's a decimal point here, but remember we can't start counting until we get to our first non-zero number. So don't count the zeros before. If we had zeros after, they would count. But we can't stop counting until this guy, so just 1. All right, so once I report my answer in scientific, I want to keep just 1. So in order to do that, I'm going to need to move my decimal. And the first rule of scientific notation says that you want one non-zero number to the left of the decimal point. So where's my decimal going to go? Behind the 3, yes. So this is where the new one's going to be. That way I just have 1 to the left. So it's going to be 3 times 10 to the, and now we need to figure out the exponent. And this exponent that's going to go here is the number of times I have to move that decimal to get it where it originally is to where I want it. So it's 1, 2, 3, 4. Now you're not done, because you need to figure out, does that stay positive or does it need to be negative? Negative. There's 2 ways to remember whether it's supposed to be positive or negative. One way that people like is, okay, I moved to the right. So that means it's negative. Another way is the original number was much, much less than 1. It was 0.0000. Okay, so either way, negative. All right? Sig figs, just an extra check. 1 there, 1 there. That checks out. All right. Let's count the sig figs in the next one. How many sig figs in this guy? I know that 2 counts, but do the zeros?
Yes.
Both of them? Yeah, they do. How do you know that?
Because you already started counting and you have a decimal point.
Right, there's a decimal and we started counting. That's the important part, and we started counting. Because if it was just the decimal point, these zeros would have counted. But we need to make sure we start counting first. So we have 3 total. Where do we want our new decimal when we write it in scientific? After the 2, between the 2 and the 0. Okay, so it's going to look like 2 times into the... How many times do I have to move the decimal to get it here? Just 1, and this time I moved to the left. Okay, and the original number was less than 1, more than 1, sorry, more than 1, it was 20. So this is going to remain positive. Is that correct?
No.
No, what did I forget?
You need 3 C6 over there too.
I need 3 sig figs, so you have to remember these 2 zeros. We said they counted, we have to bring them over. Now this is a multiple choice test, but I am going to give you this option. Okay, that'll be another option. I'll probably give you it with 10 to the negative 1, and then maybe even the correct sig figs with the negative 1. So this would be your A, your B, your C, and your D choices. So you need to know that it's a positive exponent, that you need 3 sig figs, because all those other ones are incorrect. Okay. All right, last one. So, sig figs, start there. 3 again. Where do I start counting? 4, 8, and then that 0 is going to count. All right, so we got 3. Our new decimal point, we want to go between what 2 numbers? 1 and 8. So I'm going to get over here 4.8, 0. I'm bringing the 0 in to get 3 sig figs. Times 10 to the, how many times do I have to move it? 2, what direction? Negative, right. Questions on these ones? I'm kind of going through them fast. Either you forgot about this stuff and are having trouble with it, or you've been doing it for so long that you're like, yeah, let's move on. It's kind of a combo here. All right. Let's go the other way, just make sure that we have it figured out in both directions. How many zeros? 3 zeros. All right. So that's all scientific notation. Right? We know this because there's just one number to the left of the decimal in each example, and there's exponents. So how you go from scientific to normal is you're looking at the exponent itself. So this exponent is going to tell you not only how many times to move the decimal, but in what direction. Okay, so it's a positive 1. So we know we're moving the decimal point 1. But what does the positive tell us? The positive tells us what direction. So since it's positive, do I want this number to get bigger or smaller?
It's the first.
I know I'm going to move it once, but the question is, do I want to move it to the right to make the number bigger, or to the left to make the number smaller?
You move it to the right.
It is going to be to the right. So anytime you see positive, you're making that number bigger. So to the right. Anytime you see negative, you want to make that number smaller. So you're going to move to the left. So we said bigger 1 time. New decimal goes here. So we get 42.7. 2.1000, and I didn't count sig figs there. That was my mistake. There's 3. Hopefully you all know that because there's no zeros, so it's not even any tricky ones on this one. So they're all not zeros, they all count, so we just kept them all. All right, let's count the sig figs on this one before we move. I know that the 2 and the 1 count. Do the zeros after the 1 count.
Yes.
Yes, because there's a decimal point. So we have a total of 5. So So that means we need to keep 5 digits over here. All right, we need to move that decimal point. We need to move it how many times?
Or
Are we going to make the number bigger, moving it to the right, or smaller?
bigger.
Bigger, so 1, 2, 3. So my new decimal point is going between the 2 zeros here. So it's going to be 2, 1, 0, 0, point 0. The reason I had to keep a decimal and that 0 is so that I still have 5 significant figures. All right, last one before conversions, everybody's favorite. Let's move this decimal 5 times. This time it's negative, so opposite direction than we've been going. We're making the number smaller. So 1, 2, 3, 4, 5. So what's going to go in those empty spaces? Zeros. So we're going to have a total of 1, 2, 3, 4 zeros. So decimal 1, 2, 3, 4 zeros. 1, 5. Is that correct? No, what I forget?
You need that 0 at the end for 3 6 6.
The significant figures. So this would be incorrect. I moved it the right amount of times, but my significant figures aren't right. Because if I would have counted right away, I would have noticed the 1 counts, the 5 counts, and the 0 counts. So since that 0 counts, I need to include it over here. Now it's correct. So just little mistakes like that, you can easily pick the wrong answer. That's usually where people get it, or the sig fix. So once you get done doing all the calculations and moving these kind of, it's like, oh, got it. And forget about the little things. All right, we're gonna do 525. We're gonna do the following conversions and give answers in the space provided. So, whenever you're approaching a conversion problem, look and see what type it is. And what I mean by that, is it metric to metric or is it English to metric? So if you remember, metric to metric, you're going to have that letter in common when you're looking at the units. English to metric or metric to English, you won't. So, what type is it?
Metric to metric.
Metric to metric. MG, NG. So GG, that's grams. Okay, so the reason why you want to identify is because that's just going to help you figure out what conversion sheet you need to refer to. So the metric to metric is this sideways one here, the horizontal one. And I don't think I have an English to metric one with me. The English to metric one is the up and down one, but they're both posted on Blackboard. So if you don't have copies of these, you'll want to at least have them open on your computer when you take the exam. You're going to be using these a lot. Okay. So for the metric to metric conversions, to figure out what conversion that you're using from that sheet, just look for the prefixes. Okay, so since I have 2 prefixes, milli, that's what the little m stands for, is the milli, and then n, nano, I'm going to have 2 conversion factors, one with the milligrams in it and the other with the nano in it. So I'm going to look up the milli first. So when I look up the milligram one, I follow the milli across. These are my conversion factors. And 1 milligram is equal to 10 to the negative third?
Yes.
Grams. The reason I knew I was going to need 2 conversion factors is because all of these conversion factors go to the base. They always go to the grams. Okay, so the milligrams is going to go to the grams. When I find the nanogram one, it's going to go to grams. What that means is I'm going to have to go to grams first in order to get to nanograms. So this is my plan here. Starting at the milligrams, I'm using this to get me to the grams, And I know I'm gonna need a second one to get me to the nanograms. So my second one, I look up nano on the sheet. So you follow it all the way down to the bottom. Nano, 10 to the negative 9th. Okay, so that means 1 nanogram is equal to 10 to the negative 9th grams. Is that correct? Okay. Finding the conversion factors is usually where most people have trouble. Once they start the railroad tracks, they're like, oh, I know how to cancel these. So it's important to go through the steps methodically, figure out what type it is so that you know where to start looking to begin with. That'll really help. So starting the railroad tracks, what's going to go in the upper left-hand corner of the plus sign?
525.
525, the original number given in the question. And this is the only number we're going to base our significant figures off of. We're not worried about any sig figs included in the conversion factors, just here. So I'm at milligrams, I want to go to grams. So I need to use the first conversion factor I found. Where do I want milligrams, top or bottom? Bottom. So I need it on the bottom, opposite sides of the horizontal line, cancel. Now I'm in grams. If I stopped there, I'd be in grams. But instead of calculating and stopping there, I'm just going to continue on using my other conversion factor, and I'll save the calculations for the end. Okay, so my second conversion factor will get me from grams to nanograms. So where do I want the nano portion, top or bottom? The nanos I want on top, because that's the unit I'm trying to keep. That's what I'm trying to solve for. Plus, that'll put the other half of my conversion factor, the 10 to the negative 9th grams on the bottom, making them on opposite sides of the horizontal line, canceling out. So now you'll notice the only units I have left are my nanograms. That's what I want. So now I multiply across and then divide by what's on the bottom. So I get 525 times 10 to the negative 3rd times 1. On the bottom I get 1 times 10 to the negative 9th. And your calculator might give it to you in normal notation, and it might give it to you in scientific notation. It just depends on your calculator. These aren't the answers going this way. Does anyone calculate that? Know what it might be?
It's 6 zeros behind it.
6 zeros behind the 5. 1, 2, 3, 4, 5, 6. Double comma. So that's 1, 2. So these are both correct. One is in scientific, one is in normal. What did I forget though?
Sig.
So let's look at sig figs. How many do we need?
3.
3. So we have 3 here. Down here, do these zeros count?
No.
No, they're commas, not decimals. If decimals, the zeros would have counted, but since it's commas, they don't. So my sig figs are good. There's one more piece of information I need to add to it.
The units.
The units. So you need the units, and I will try to trick you in the multiple choice and give you incorrect units on the right answer. So look at your units. Okay. So it's NG. Whole reason we did this, right? We don't want to forget that part. Questions on this one? Try another one? All right. So we'll move to 5B if you flip the page over. There's another conversion. And 740 millimeters to inches. So what type? Is it metric to metric or English to metric? English to metric. We don't have a letter in common. And you might even realize that inches, well, that's English. That's what we use here in the US. So it's definitely not metric. All right, so when you have English to metric, you're looking up a conversion factor from that vertical sheet that's separated into length mass and the other one, volume, thank you. So what you're trying to find is a conversion factor that gets you from millimeters to inches. If you can't find one that gets you there in one step, that means you're going to have to do 2 steps. So if you can't find one that gets you from millimeters to inches, try to find one with inches in it that gets you anywhere in the metric area. Hi, so is there one that gets me from inches to somewhere in the metric area? Centimeters. So centimeters is going to be in the metric area. So it's 2.54 centimeters equal to 1 inch. That's what we're talking about, right? Okay, so if I can get from centimeters, I like to write a plan. If I can get from centimeters to inches using this, I can go from millimeters to centimeters. So how do I know I can go from millimeters to centimeters?
You have a letter in common.
They have that letter in common. This is my metric to metric step. Okay. And remember from last week, we can even use a shortcut on that one. So what I mean by that is with metric to metric, we draw an arrow down here so we're not thinking this is English metric. We talked about this scale for a shortcut. Now, why didn't I use this scale on the last problem? This scale wouldn't have worked for the last problem because these are the prefixes for the metric system. They're the prefixes that you see on the conversion table, okay? And they go from kilo down to the milli. And our last problem that we just did, it went way down to nanograms. So it went past this scale. So that's why we had to use this conversion factor sheet for that one. But this one, millimeters to centimeters, we have millimeters and we have centimeters. So we can use this scale, and it's going to save us a lot of steps. Okay, so for the metric to metric step, we'll use the scale. For the centimeters to inches, we already found a conversion factor for that. All right, so let's do it. Let's start the problem. We know our plan, so we can go ahead and get started. So for this first step, going from millimeters to centimeters, so I'm just going to write it like it's a regular conversion factor. If I want to go from 740 millimeters to centimeters, I said I could use that scale over there because it's within the right range. So to use this, I just need to know where I'm starting, which is the milli, and where I need to go, which is going to be the centi. Okay? What do you think goes in that empty space? Does anyone remember? It's going to be an M. It's the comment. Whatever letter's the one in common, in this case an M, that's what's going to go here. Because this is metric to metric. This can work for mass. And if it's mass, we put grams. It can work for volume. So then we put liters. It can work for time. Then we put seconds. If you were doing physics, you could put newtons and a whole bunch of other things in there. Okay? It's a really nice scale. So we starting at the M, and we wanted to go to the C, right? So to get from the M to the C, we're moving the decimal 1 time. Right? That's it. They're right next to each other. What direction did I just go? To the left. So that means when I go over there to move the decimal, I'm going to move it once to the left, just like I did here. So starting at 740, starting at the original number. There is no decimal point, so where do I start? At the end of the number. Okay, and I just said once to the left. So it's now going to go between the 4 and the 0, so that's going to give me 74 cents. So I'm now in centimeters, and I want to go to inches. So I'm going to start with this number now when I do my railroad tracks. I'm not starting with my original because the railroad tracks is just for English to metric conversions. Or I should say it's just for when we have conversion factors, not just for English to metric. And I need to start with this number in centimeters so that I can cancel out the centimeters in my conversion factor. So do I want the centimeter portion on the top or the bottom? Bottom, we want it to cancel, so it needs to be on opposite sides of that horizontal line. Centimeters, centimeters. So this time I'll be dividing. Okay, so I'm going to be taking 74 times 1 divided by 2.54. So let's count sig figs first so that when I ask for the answer, you guys can round it for me. So looking at sig figs, you look at the original number from the very beginning. How many? 2. Why does that 0 not count?
It's not between two numbers.
Yes, for several reasons. It just doesn't count. There is no decimal. Okay, so I need 2 sig figs in my answer. So what is the answer?
29.
29 units?
Inches. Inches.
It is inches, yep. So it's the only units left that didn't cancel. All right. So we have time for one more problem. What's the next problem? Is it number 6?
Mm-hmm.
Okay. So most people I've had in one class, so I just printed out just enough so that I don't have one. So could someone read me the problem?
3.60 plus 0.089 minus 0.002345.
Oh, so this is just a reminder of how to do the rules for addition. So all the conversions and everything that we've been doing are multiplication and division. And when we multiply and divide, we look at the significant figures as a whole. So we've kind of gotten into this habit where we're like, oh, I need to count my total sig figs, whichever one is least, that's going to be what I report my answer in. And then we forget, since we rarely do addition and subtraction, the rules are different for addition and subtraction. We are not counting the sig figs as a whole. We are looking just after the decimal point. Okay? So let's count just after the decimal, how many decimal places each number that we're using has. So starting at the first guy, how many decimal places? So 2, and I'm going to put DP instead of SF because it has 3 significant figures, but since we're adding and subtracting, we're looking at just decimal places. So how many decimal places in the second number?
30.
It's going to be 3, so even though it's a 0, I know it's not a significant figure, but it does count as a decimal place. So it will be 3. And then the last one, a lot. 4, 5, is that 6? Actually, it doesn't even matter if it's 5 or 6 because we're picking the smallest. So which number is smallest?
2.
So that means when we report our answer, we're going to report it to 2 decimal places. All right, so someone want to calculate that for me? That's
3.686655.
okay, so obviously we don't want all those digits, so that's why we did this whole decimal place counting thing. We said 2, so go over to your number. Start at the decimal place and count 2 spots after. Don't forget to look at the number next to it. Is that going to stay at 8 or round up? It is going to go up. So it would be 3.69. So I went out 2 decimal places, but how many total sig figs are in my answer? So 1, 2, 3. 3 sig figs. So pay attention to the question itself. Because I might give you an addition and subtraction problem and say, how many significant figures are in your answer? There's no way for you to know that unless you calculate it out, you count out the decimal places, and then count the sig figs in your answer. Okay? Okay, I'm not asking you how many decimal places your answer should have, I'm asking you total sig figs, and to figure that out, you have to calculate it out. So, on Friday, I'm going to go through the rest of this, so you're welcome to come in and listen firsthand, otherwise I will just be posting a video. So I'm going to go through the rest of those questions on that one-pager sheet, and then whatever time I have left, I'm going to do the last page of problems on the packet. Okay, I'm skipping the definitions because you have a book, you have the PowerPoints, you can read and write the definitions yourself. It's more the problems that I'm concerned about, because that's usually where people have more difficulty. Okay, did you need a packet?
No, I already have a copy.
Okay. All right, so don't forget to do your homework questions for chapter 1C and your discussions.